Ahoy! Here we are with chapter 8, lesson number 7, tangents to a curve. Now if you remember in the last lesson we were looking at the discriminant, and the discriminant is used to determine the nature of the roots of a quadratic. But it also has another purpose in higher maths. It can also be used to determine if a line is a tangent to a curve. So, let's begin. Tangents to a curve. So to find out if a line cuts, touches, or does not meet a curve, the straight line equation is substituted into the equation of the curve. What you'll get out is a quadratic. So with that quadratic, you then take the discriminant and you use that to find out the number of points of intersection between the line and the curve. What you'll find out is that the discriminant will either be less than 0, equal to 0, or greater than 0. If the discriminant is less than 0, this means that the line does not intersect the curve, and you will get something that looks like that. It's where they do not meet. If the discriminant is equal to 0, then it means that the line is a tangent to the curve. And remember, a tangent is just going to be touching in one place. So you'll get something that looks like that. And if the discriminant is bigger than 0, it means the line intersects the curve in 2 or more places. So you will end up with something like that. Let's do some examples then. So example 1, prove that the line y equals 2x minus 1 is a tangent to the parabola y equals x squared, and find the point of intersection. So the first thing you want to do is you want to substitute the equation of the line into the equation of the curve. So because you know that y equals x squared, you can replace y with x squared. So we've got x squared equals 2x minus 1. So you're just using substitution. From there, you will then take everything to one side, so subtract 2x from both sides, add 1 to both sides, and you get x squared minus 2x plus 1 equals 0. And there's two different ways that you can go about doing this one. First method is just what I said on the last page. So you can now use the discriminant. So take the values of a, b, and c, so 1, negative 2, and 1, and sub them into b squared minus 4ac. If you do that, you get 4 minus 4, which works out to be 0. And remember, since b squared minus 4ac equals 0, it means the line is a tangent to the curve. So that's, you proved that. We also want to find the point of intersection though. So what you do with that is you need to find the value of x. From here then, because you know that x squared minus 2x plus 1 equals 0, you can factorize that in order to find the value of x. Factorizing gives us x minus 1, bracket x minus 1, meaning then the only point that it touches will be x equals 1. That kind of leads us into the other method that you can use to solve this. You know that if a line is a tangent, there will only be one value of x. So what you could also do is you could say that x squared take 2x plus 1 equals 0. If you factorize that, you get x minus 1, bracket x minus 1, meaning the only value of x is going to be 1. So you could also have said that since there is just one point of contact, the line is a tangent to the curve. So one method or the other, doesn't really matter which way you do this one. Either way though, if you want to find the point of intersection, you'll also have to find the value of y. To do that, you know the value of x, so sub it in to one of the equations. I'm subbing it into x squared, and I get y equals 1. Double check by subbing it into the other. 2 times 1, take away 1, you also get 1. It works out. That means that the point of intersection is 1, 1. Example 2. Show that y equals 2x plus 7, so that's a straight line, is a tangent to the curve y equals 6 minus x squared. And once again, find the point of contact. So to do that, again, you know that y equals 2x plus 7. You also know y here equals 6 minus x squared, so you can just use substitution, replace y, and you know then that 2x plus 7 would equal 6 minus x squared. From there, you want it in the form ax squared plus bx plus c equals 0. So from here, I'll add x squared to both sides, subtract 6 from both sides, and that gives us x squared plus 2x plus 1 equals 0. From there then, once again, you can do this two different ways to show that the line is a tangent. One way is to use the discriminant, so b squared minus 4ac. That will give us 2 squared minus 4 times 1, which works out to be 4 minus 4, which again works out to be 0. So since b squared minus 4ac equals 0, the line's a tangent to the curve. To find the point of intersection, the point of contact, once again, you need to find the value of x. So to get that, take the quadratic when it's in the form ax squared plus bx plus c and factorize it in order to find the value of x. Here, if you factorize, you would get x plus 1 bracket x plus 1, so x would equal negative 1. Once again, you could have gone down the route. If you know that the line's a tangent, then there will only be one possible value of x that you get. So you could also have factorized straight away. You get x equals negative 1, really means there is a repeated root. There's only one value of x, so you can say that since there is just one point of contact, the line is a tangent to the curve. After that, you need to obviously the value of y, so take the value of x and sub it into one of the equations. Here I'm putting it into 2x plus 7. After that, you will end up with 5. So the point of contact will be negative 1, 5. Whatever you get, just check it in the other equation. That would work out to be 6 take away 1, which again works out to be 5. So you know you're right. Woo! Well done. Here we go with example number 3. Find the value of c for which the line y equals 5x plus c is a tangent to the parabola y equals 2x squared plus x minus 5. So how do you do this one? Well, again, you're asked to find the value for which the line is a tangent to the parabola, to that curve. So to do that, you're wanting to substitute the equation of the line into the equation of the curve. So because you know y equals 5x plus c, you can replace y with 5x plus c. So you know all of this, 2x squared plus x minus 5 must be equal to 5x plus c. Again, you're just using a substitution. From there, you want it in the form of your quadratic, ax squared plus bx plus c equals 0. So subtract 5x from both sides, subtract c from both sides, and this is what you would end up with. From there, you're wanting to think 2x squared plus x minus 5x will give 4x, and the negative 5 and the negative c, you put them together. They're both going to be your constant. So the way I'm writing it here, I'm adding on a negative 5 and a negative c. Find the value for c for which the line is a tangent. Well, how would you know that? Well, that is when you're wanting to use the discriminant. So for the line to be a tangent, there can be only one point of contact. So to find that, you would say that b squared minus 4ac must equal 0. So take the values of a, b, and c. A would be 2, b would be negative 4, and c would be the negative 5 minus c. B squared minus 4ac equals 0 then, because it is a tangent. It tells you that it is a tangent. Find the value of c. So you can then say that b squared, negative 4 squared, minus 4 times a, which is 2, times c, which works out to be negative 5 take c. Multiply out the brackets, 16 plus 40 plus 8c equals 0. In other words, 8c equals negative 56. Add them together, you get 56. Subtract 56 from both sides, you get that. And divide both sides by 8, and c would equal negative 7. And that is the value that you are after. Example 4. Find k if y equals x minus k is a tangent to x squared plus y squared equals 8. So for this one, once again, you know that it is a tangent. So this line here, y equals x minus k, can be subbed into this equation of the curve. So you can say that x squared plus, and you're replacing y here with x minus k. So instead of y squared, you've got x minus k squared equals 8. Multiplying out the brackets gives us x squared plus x minus k times x minus k equals 8. Multiply out the brackets, you would get x squared minus xk minus xk is minus 2xk, and then plus k squared. From there, x squared plus x squared is 2x squared. You'd have minus 2xk plus k squared minus 8, and that would equal 0. Again, for the line to be a tangent, there's only one point of contact. It's telling you here it's a tangent. Find k for which it is a tangent. So you know that the discriminant, b squared minus 4ac, must equal 0. So start off writing down the values of a, b, and c. The coefficient of x squared is 2. The coefficient of x, well, you're multiplying x by negative 2k, so that would be the value of b. And the value of c, the term without an x or an x squared, is k squared minus 8. So that is the value of c. You know b squared minus 4ac equals 0 because the line is a tangent. So sub in a, b, and c. And you've got negative 2k all squared minus 4 times 2 times k squared minus 8 equals 0. From there, multiply out the brackets. So 4k squared minus 8k squared plus 64 equals 0. 4k squared minus 8k squared gives us negative 4k squared plus 64 is 0. And from there, you're wanting to solve that. Because you've got a negative 4k squared, I'd probably add k squared to both sides and subtract 64 from both sides to give us 4k squared minus 64 equals 0. From there, you want to find the value of k, so I'd factorize, take out 4 as the highest common factor. And then here, k squared minus 16, well, that's the difference of two squares. You've got k minus 4 and k plus 4. So you get two values of k. You've got 4 and negative 4 by setting each of these brackets equal to 0. And that is example 4. Example 5. Find the equation of the tangent to y equals x squared plus 1 that has a gradient of 2. So a slightly trickier question this time. So find the equation of the tangent to that curve that has a gradient of 2. Well, you know the equation of the tangent is going to be a straight line. And you know a straight line is of the form y equals mx plus c. And here you know the gradient is 2. So you know then that the straight line will be of the form y equals 2x plus c. From there, you know that y equals x squared plus 1 and y equals 2x plus c meet when one equation is substituted into the other. So because they're both equal to y, they're both equal to each other. So you can say that x squared plus 1 equals 2x plus c. Subtract 2x from both sides, subtract c from both sides, and you would end up with x squared minus 2x plus 1 minus c equals 0. That's just rearranging this. From there, you know that the line is a tangent. It tells you that up there. So you know b squared minus 4ac must equal 0. Find out the values of a, b, and c then. A is the coefficient of x squared, which is going to be 1. b is the coefficient of x, which is negative 2. And c would just be 1 minus c. Sub them in to the discriminant, b squared minus 4ac. If you multiply that out, you'd get 4 minus 4 plus 4c equals 0. 4 minus 4 is obviously 0, which means 4c is 0, which means c would be 0. Therefore, the equation of the tangent is going to be y equals 2x plus 0, or in other words, y equals 2x. If you did go off and graph that, you would end up with this, which you can clearly see. You've got y equals x squared plus 1, and you've got y equals 2x. And there is that point of contact right there. Example 6. Find the equation of the tangents from 0, negative 2 to the curve y equals 8x squared. So for this one, you're not given an awful lot of information. You've got a curve here, y equals 8x squared, but the only point you've got is that 0, negative 2. However, you know if it's a tangent, then it's going to be a straight line. Again, it's y equals mx plus c. But this one here, because it's passing through 0, negative 2, well, that's a point on the y-axis. That's your y-intercept. So you know the equation of the straight line then is going to be y equals mx minus 2. Woohoo! So you know sometimes more than you maybe first think. Whoops. From there, you've got y equals 8x squared, and you've also got y equals mx minus 2. And you know they are going to meet when, set them both equal to each other, 8x squared equals mx minus 2, because they're both equal to y. So we're substituting one equation into the other. If you rearrange that, subtract mx from both sides, add 2 to both sides, and that is what you would get. Since it's a tangent, you know that the discriminant must be equal to 0. So since lines are tangents, b squared minus 4ac equals 0. So write down the values of a, b, and c. So the coefficient of x squared, the coefficient of x, and the number that's just on its own. Sub them in to b squared minus 4ac, and you'd end up with negative m all squared minus 4 times 8 times 2, which will give you m squared minus 64. From there, you want to solve that for m, so you can use highest common factor. No, you can't. You could use difference of two squares. Yeah, you can. So difference of 2 squared, m minus 8, m plus 8. So you know then m would be positive 8, or m would be negative 8. Meaning then that you're going to have these two values for m. But the straight line up here, we saw that the tangents will be of the form y equals mx minus 2. So we know we're going to have these two straight lines. So there will be two tangents. We'll have y equals positive 8x minus 2. And we'll also have y equals negative 8x minus 2. Again, you could go away and check that and graph it. And if you graph it, that is what you will find. So there is the curve, y equals 8x squared, and that is your two tangents coming from that 0 and negative 2. That line is touching just at 1 point, and this straight line here again is touching just at 1 point. Try the questions on your own, see how you get on. This is in the Heinemann Higher Book, page 161 onwards, exercise 8J. Good luck. Have fun. Bye-bye.